Hi, my name is Alex Afanasyev. I'm assistant professor in the Florida International University, and I want to welcome you to this virtual presentations of our ICN-SRA workshop. Today, in this talk, I will be talking about NDNconf, Network Management Framework for Named Data Networking. So, what is basically the motivation of the work? We have been having this NDN named data networking architecture for a while, and one of the missing pieces we had so far was network management. Effectively, we can manage the network, but what we cannot do is do it in NDN way, meaning like you issue NDN commands, you configure the routers in all aspects of the routers, you issue a command to configure the network. So that's one of the things that needs to be done, and that's a direction of the work that to be proposing as part of this NDNconf. The management needs to be flexible, extensible, modular, to all this extent, so we can actually leverage a few components that already exist as part of the existing management system. Another aspect that we actually want to do is to support multi-point to multi-point management, meaning not necessarily, obviously not a single device being managed. Beyond that, we also want to manage the network as a whole, and not necessarily a single management point controls the whole network. And most importantly, we want to have very flexible and very high granular security. So just very brief introduction to NDN. I'm assuming everybody knows about NDN. But effectively, NDN is a named data networking architecture, as the name suggests, where data is the centerpiece of the architecture. So it's what you do in NDN is you assume everything is expressed as a data. So therefore, you can express the interest to the network and use name, very URI form name, to ask network for that piece of data, and the network will give you that piece of data, and that data is basically secured. There's a tons of advantages of this approach, including the multicast capabilities. So because we do stateful forwarding, there's a lot of caches that can be supported in the network. There's a stateful forwarding you can avoid loops. You can do very flexible forwarding, and so forth and so on, including a very easy to create ad hoc communication. So that's the basics. So this is what we want to control using our NDNconf. And what we're trying to borrow is ideas from so-called NETCONF. So NETCONF, network configuration, is a next generation after SNMP, and what it does, it supports a lot of things. So one main component of NETCONF, beyond the transport layer flexibility, is flexibility of the modeling. So modeling in terms of what exactly can be configured. And this part is expressed as so-called Yang models, and I'll talk a little bit more about Yang models. In addition to just basic configuration of individual devices that you can do, there is a clear separation between different states. So you can, using the NDNconf, you can select the configuration state, you can select the actual state, running state, the startup state, and so forth. Protocol can support transactions, meaning it will either create certain configuration state, or it will reject all configuration state from all the devices. And there's a bunch of other important features. What I want to highlight here is a little bit about the Yang modeling. The special modeling language can define any aspect of the network device. And in addition to that, the protocol itself actually includes the capabilities of getting the specific model that the specific device you're trying to communicate with being configured. One thing that is very nice as part of the Yang model that I just showed you in the previous slide is it actually have a quite nice alignment with NDN. If you noticed the very small code I showed previously, and if I basically convert that code in a small diagram, you can see that everything is quite hierarchical. And basically any leaf can be transformed to a name following this hierarchy. And you can actually reuse these names at a later stage to define what you want to do. And in addition to that, same stuff can be told about the commands. All those can be expressed as names. So this is basically motivation and a basic approach of what NDNconf essentially is or become. What we're trying to do basically leverage all parts of naming that exist as part of the AI model and just bring them to NDN world. So first of all commands we want to express either interest or signed interest. To retrieve information, set information, subscribe stuff. In addition to information itself being published as a kind of data packet effectively, the models themselves can be published as a data. So this one is one step further from the existing NetConf, where it kind of the model exists. There's actually a name of the model in existence somewhere, but you have to connect to that specific device. You have to negotiate with this device, retrieve the model, versus in NDNconf, you can just express the name if you know what kind of model in existence that you want to configure this specific part of the network. So you can just express this name, retrieve the model, and start doing configuration. And another part that is extremely unique to NDN and NDNconf specifically is leverage the naming to realize security. So in kind of maybe instead of basing all the security on the connection, in here we can kind of try to use names, and I'll show you a few examples later, to define that we can access to the whole complete model, or you can only control the branch of the model, or you can only have access to a very single, very precise part of that model. Like for example, you only can get status of a specific subset of faces on NDN router. So what kind of models are we actually talking about as part of management? So first of all, we can certainly reuse any existing NetConf models that kind of for general configuration of devices. There are tons of different models in existence, and I gave you example of IETF interfaces model. And if you're interested, you can go on this link on GitHub and see all kind of various kinds of models that defined for Cisco, for different and some bunch of other vendors of networking hardware. The second one, kind of basically one of the main motivation here is to generalize the existing NDN management. So for several prototypes, we have developed kind of management protocols, and kind of we developed basically control commands, notification streams, and so forth and so on. But those are very specific to that implementation, and a different implementation not necessarily follows the same configuration model. And if you want to, as a management unit, you have a network that comprises several routers. One is running NFD, the other one is running in NDN DPDK, then you basically have trouble. And so that would be basic management of individual devices. You kind of already can build on a higher level logic management of NDN network as a whole, but you can also build in additional stuff as part of NetConf itself. So for example, you can build the management of an LSR routing not per individual devices, but rather some higher level logic. Effectively, you can express a request to the network, but please network configure itself. So because you can use the name, you can express this request, and any device that effectively follows this network will try to comply in what is happening. I don't have a very specific example here, so this is just general idea that with the name you can try to express something not necessarily device level, but rather a little bit more generic on the network level or like sub-network part level. But again, that's a high-level idea. This is initial work, and just want to identify a few other things as part of the NDNconf. So first of all, naming is relatively simple. So first of all, initially, like in all cases, you have to identify kind of prefix of what kind of network or what kind of a specific device you want to configure, obtain state, and or do some kind of operation. I gave example of NDN UCLA first, so that would be individual router, but you can go kind of different levels. You can just do NDN UCLA, trying to get configuration for all kind of basically network of UCLA, you can also specify just /ndn to identify that you want to get the whole NDN and so forth. Not all commands will probably make sense. So for example, get config candidate NDN this faces may not necessarily apply to the whole network, but for some, as I show you about the subscription, those would make sense. So for the operations, there's a bunch of operations that basically inherited from NetConf. So you get configuration, you do the get set values, you execute some form of RPCs, and maybe additional stuff. Scope, again, very similar to what exists in NetConf. It's either some running configuration, candidate, startup, and so forth. Most important part, kind of very interesting part, is identity subject. So this one is effectively literally taken from YAML model and just following YAML model structure, that basically part of NDN name. And the last part here is actually, I mean, this is also part of YAML model, but it's actually showing the exact command that you want to execute, like get config and get to show information about the phases. And auxiliary information here is actually a lot of things that can be included in there. One part is the parameters, and I show you example about phase equal 300. But in addition, it can be signature or signature related information, a version of that request, segmented if it's need to be segmented, and some other information. Finally, so that one was for executing specific pops up on a device level. You can also do some kind of pops up network events. So this will be realized through the sync protocols, some kind of sync protocols. But effectively, what you can express is your interest to the device network or higher level network. You want to subscribe a specific state information, and just identify what kind of events you want to receive as part of this notification. So in this case, I want to get information about phases or new phases created, or we want to get or be notified about phases removed. And if model supports of getting some information about this marker interest or marker data packets, then it will be you'll be able to capture that information as part of the subscription request and get those pieces of data when they create it. And the final piece is security. I already highlighted that we try to leverage naming of individual components, and kind of already show the parts of the names of the data, and you basically can just couple this with the names of the keys. So if you possess a key that, for example, has a kind of very similar prefix, there's a NDNconf edit config, you can create a very simple schema to define that. So this key can be used to edit any configuration of that specific prefix. So it's either for the network, for the specific router, or kind of maybe part of the router. You can have another different key. If you possess that key, then you can only edit config of the running configuration. So you will not be able to change the configuration for the startup, but you will be able to change the running configuration. But you can also create more complex schemas that don't actually require you to have a key that has these specific components. Okay, so this is maybe a little bit intensive for what I was promised you to say, but I just want to make a kind of very big disclaimer that this is still the whole work is in the initial stage. So there's a lot of ideas that are thrown into you and that will not fully yet realized. So please welcome all the suggestions. But in any case, in all, it seems to be that NDNconf, at least from my perspective, seemed to be very interesting candidate to fill the gap for the network management. So it supports various features that kind of actual network management requires, plus it embeds a lot of things that NDN provides. So it provides communication part and kind of going beyond point to point, allowing you to realize any kind of multi-point communication. You can leverage security from NDN, and hopefully after we're done with the initial prototype of NDNconf, a lot of things will become simpler. Okay, so I will try to stop at this point, and I hope you will ask a lot of interesting questions, and I'll be able to answer all of them during our virtual workshop session.